Now, de Moivre's theorem, pay attention. Before we can understand de Moivre's theorem, there are two things I need to explain to you because it help you in your understanding of de Moivre's theorem. Okay, the formula actually says, pay attention. The formula for de Moivre, it says, when you have z in the power of n, and you are given your r, pay attention please, cos n theta, then your I sine n theta. De Moivre is saying that this thing you are saying can be written as this. Your z in the power of n is equals to your z in the power of n can be written as, pay attention. Please don't forget to put your hand here. R cos theta plus I sine theta in the bracket of n. That's de Moivre's. Where your n can be fraction, positive integer, or negative integer. So this is the formula. There's a way they prove it, but I don't want to pass through the process because of chemistry. I won't skip a particular one. What's it called? There's a topic I skip because of this de Moivre. De Moivre is more important than this, than that one. So look at this. What do I say? Whatever the value of your n is applicable to wherever you have your r in the power of n, is applicable to wherever you have your what? N as theta, n as what? Theta. So this thing you are seeing can also be written like this. Z in the power of n equals to, look at it now, where is the n? This is the n, Abi. So the n, which is here, bringing it together with the n at this side. Are you seeing that? They are brought to the top. Yes or no? The n is not a power. It's like a number. Second bracket, the n is what? A number. So when I bring it to the top, the n is at the top. Why this Rn is at the top here also? So that's what de Moivre is saying. So this de Moivre, they used to solve questions. Let's give an example. Let's assume I said, if sample 1, if, hello, attention, if z is equals to r cos, let me say, 3 cos x plus I sine x. Find z in the power of 2, z in the power of 1 over 3, z in the power of 1 over 2. Minus, Abi? Minus 3, let's minus 3. According to de Moivre's theorem, what will we do? Solution. We say what? Z, which is in the power of 2, can be written as what? 3 what? Squared. Then what? 3 cos 3x plus I sine 3x. Are you seeing that? So am I done? No. What's this? 9 in bracket cos 3x plus I sine. You solve 1. It's not as simple as that, but you solve 1. The 3 is coming from the question now. Eh? The first one now. Look at it. Look at the first one. Wait. Calm down, calm down, calm down, calm down. Yeah, listen, listen. Let me come again. This Zn, Abi, R in the power of what? N cos n theta. It means n times t theta. Then sine n theta. N is 2. Hey, sorry. It's called 2s, Abi. I'm sorry. Emma Binu Ejo. I'm sorry for that. Is that all? Should I go on with it? What? Is that your Z? That's Z. Yeah, it's E or Z. It's Z now. Wait, please. Let me say something. Let me say something. No, I'm live actually. There are some questions you shouldn't ask for a joke. I will believe it's a joking question. I'm writing Z is money. It's not E. So what do we have? Z in the power of what? 1 over 3. How will it be? Will that be what? 3 in the power of what? Cos 1 over 3x plus I sine. Is it clear? Simplify this guy. What will he give you? The root of what? Then what do I have here? Cos x over 3. Then I sine x over 3. The Moivre's theorem. Taking it gently. I'm going somewhere now. What if it's a negative sign? When z, okay, someone asked a very good, that's why it's good to ask questions. Please, if you look at this carefully, you'll be asking me, 2x is common, isn't it? Yes. Can I bring it out? Can I bring out the 2x? Why? It's going to affect what? That's not the reason. Very good. It's for the theta. You can't bring out it. Imagine I say sine square theta. Follow me. Plus cos square. And I say, okay, theta is common. So theta is now sine square cos square. So that's it. Let's try this. Minus 3. So here will be 3 in the power of minus 3. Okay. Bring it out. Yes. You can. No. No. Okay. No, you have to differentiate real part and imaginary part. Yeah. That's separate it. So here what will I have? Cos what? Minus what? This is an angle, not what? A number. I know most of you want to say, let us bring the s to the front. Abi? Which is wrong. It's not a number, it's what? An angle. So put it as minus what? 3s plus I sine minus 3s. Then this is what we have. So when you simplify this, we are going to have it as 1 over 9 over cos in bracket. Say thank you. 1 over 27. Sorry. Then I sine minus 3x. That's the answer. So let's go to the real work.
Yeah, you wrote z raised power n is equals to this. So here our n is 2.
Yeah.
So it will be cos, only because square theta plus I
Right.
sine square theta.
No. Look at it. It's from where I got it from. Before it was Zn, Rn, then N, then N. So this N you are seeing, they were brought outside as this.
But yeah, it's raised to power, so it will be cos square theta.
No. Actually, this is how it look like. This is formula. This is the law. There's a way they prove it to look like this. I see that. Don't think it's a square. It's with the angle n theta. N theta. So when you want to write it like this, the n is brought from this one, but the n also is coming from it, not as a power, but
So
as
why
a
is
number.
power?
That's so they prove it like this. There's a way they prove it
Okay, they prove it.
to be like this. So when you are doing it, don't put the n as a power. You put it as what? number. So for this case, the n will be a power. You understand?
For the other, it will be number.
Number, exactly. So let's go to the one that I want us to solve question. Using the Moivre's theorem. Yeah, sample 2. Expand cos 3 theta plus I sine 3 theta. Use the Moivre's theorem. Expand cos 3 theta plus I sine 3 theta. Guys, are you with me? Yes. Let's solve this. Now recall, the Moivre's told us that anytime we have z in the power of n, isn't it? Is equals to, and we have Rn, then cos 3 n theta plus I sine n theta. How will you write it? Now Zn is equals to what? R, isn't it? In bracket cos theta plus I sine theta in the power of what? N. According to what? Oh, thank you. Thank you very much. All in what? N. What do you observe? This N is carrying the power, this R is carrying the power of N. And it turns to this. This N is beside the angle. This N is beside the angle. Then it turns to what? Power, yes or no? Can I also apply it to this case? Since here is cos 3 theta plus I sine 3 theta, can it be written as cos theta plus I sine theta in the power of 3? Is it correct? Yes. So let's do something. Let's assume binomial expansion is coming in. Assume that A is equals to what? Cos theta. And B is equals to what? I sine. So what do we have? A plus B in the power of. Now, using binomial theorem, Pascal triangle. B should use Pascal triangle. Pascal triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3. When the n is the power of, n the power of, n the power of, n the power of, what's n here? 3, Abby. So we say 1a in the power of 3, starting from the power, b in the power of what? 0, which is this, plus the next one, 3a, then the next one, the next one, then 1, Abby, power 0, 3. So in this case, I can also write it by saying a in the power of 3, 3a square b plus 3ab square plus b. Are you seeing it? Now the question now, return back the value of what? A. And what? So what's our A? 3. Now will it be 3 theta or square theta? Sorry. Will it be cos 3 theta or cos cube theta? The Moivre is telling us this will be what? 3 theta. But binomial expansion never tell us it to be what? 3 theta. It will be what? Cube theta. Exactly. So at this case, here should be cube. This cos what? Plus 3 cos square theta, Abi? I sine theta plus 3, then cos theta. Then what do we have? I sine square theta or no, I sine theta all squared. Then the last one is now what? I sine theta to the power of 3. Where? This one. Three day here now. Three here, three here. Three no day here now. Is 1, 3, 3, 3. So what do I have? Everybody write it out. Cos what? Cube theta, then what? I, thank you. I sin theta. Then what do we have next? 3. I square sin square theta. I square sin square what? Theta. Then the last one is now what? I cube sin cube theta. What's our I square? Recall that I square is minus 1. I cube is what? Minus I. Do you remember that formula? So what will I have? Cos cube theta plus 3 cos square theta I sin theta minus, because here is I square. 3 cos what? Theta sin square theta. Then what do I have here? Minus what? Minus I sin cube theta. Now separate them in real part and what? Imaginary. How do we know imaginary part? The one that has I. So separate them. What do we have? Cos 3 theta. Does it have I? No. Minus 3 cos sine square theta. For this case now, there is I here and I here. So we have it as plus 3 cos square theta I sine theta. Then at this side, minus I sine cube theta. Now bring out the I that is common here. So how do we have it now? Cos 3 square cube theta. Then 3 cos, no, we are still on this side. So let me use a bigger plus to separate them. So I is outside now. Because when you bring out the I will now be left with what? 3 cos square theta sine theta. Abi? Minus sine cube theta. That's it. That? Eh? Where's theta? I didn't show you any theta. Oh. The Moivre theorem. Pascal. That's binomial theorem. For this case now, Pascal triangle. Start with 1, end with 1. Start with 1, end with 1. Start with 1, end with 1. So 1 plus 1, 2. 1 plus 1, 3. 2 plus 1, 3. That's it. When you go on, 1 plus 3, 4. 3 plus 3, 6. 3 plus 1, 4. I taught that in my last class. Math class. Binomial theorem. We did it now. Yeah. So this is how you do it. Can you see me left to answer? The Moivre theorem. It will tell you to expand using what? The Moivre theorem. Let's solve one more. The last one that might look somehow tricky and hard. Sample 3. Now, this one is a little bit tricky. Obtain the expression for cos 4 theta in the respect of cos theta. Obtain the expression of cos 4 theta in the respect of cos theta. Now look at this, please. Solution. We want to get the value of what? Cos 4 theta using what? The Moivre's theorem. And how do we do it? We can't get cos 4 theta without knowing what? Sin 4 theta. So I can say, through the Moivre's theorem, cos 4 theta has a relation with I sin 4 theta. Are you seeing that? We have to find this cos 4 theta in the respect of what? Cos theta. But we cannot know it without getting what? So if you want to do it, you have to carry along your sin 4 theta. Are you with me? So how do you now write this? You say cos theta, isn't it? I sin 4, theta in the power of 4. What will I do now? Now, because, listen to me, because we are asked to find in the respect of what? Cos. Let's say, let cos theta be what? C. And let what? Sin theta be what? S. Do you understand? So how will I write it? I will say C plus S. Please, let I sin theta be what? S. So I will say C plus S in the power of what? 4. Pascal triangle. What's my first coefficient? No, here is 1, 4, 6, 4, 1. So at this side I have it as what? 1, C, 6 coming first. C in the power of 4. Let's leave the X plus what? 4, C, 3, S. Then, you don't need to put the 1 there. It's the same thing. 6, C2. Then what? Then what? 1S4. Thank you. Is that not it? Can we clean this side? So how will I write it now? What's my C, everyone? Cos theta, B. So we say cos theta, isn't it? In the power of what? 4 plus 4, the same thing here. Cos theta in the power of what? But what do we have here? I sin theta. The next one, plus what? 6, Abby. Cos theta, power of 2, I sin theta all squared. Plus 4, just cos theta, Abby. Then in bracket, I sin theta cube. Plus I sin theta all. Isn't it? Abby now. The goal, pay attention, is very interesting. Let's, all those that has I, especially this one has I squared. Later we have I squared. Is there I squared here? Well, we have I here also. I cube. So let's find a way we simplify them. Here will be what? Cos 4, Abby. Then this side will now be, the I is there, isn't it? Now will be 4 cos cube theta I sin theta plus, be careful, I squared is minus. So here will be what? 6 cos squared theta sin squared theta. Now what happened to this I? Minus I. So that's minus times plus. Minus 4 cos theta I sin, no, cube theta. I remember that I in the power of 3 is minus I. The minus affected this one now. So let's go. This one now will now be what? 1, Abby. Sin what? Separate them. Sin 4 theta. Thank you. When we separate them, what we have? Look at it. Cos power 4 theta, there's I here, Abby. There's no I here. Minus 6 square theta sin square theta plus sin 4 theta. Where there's I, these two guys. So that means plus 4 cos in power of theta I sine theta. Abi? But without wasting much of our time, can we bring out the high? Let's bring out the high from here. I, then what else again? In bracket, 4 cos. Can we also bring out the 4? Can we bring out the 4 here? There's I here, there's I here. So 4I, 4I. So is it minus or plus? It should be minus, isn't it? Because here is already minus. There is plus. That's 4I or I4. Thank you. I4, then plus. Yes, it should be plus. That's because this cos 3 theta sine theta minus cos theta. That's it. And this side, this cos 4 theta, cos 4 theta. This one here, this is it. Why am I breaking this and this together? They don't have what? I. So they are called the real part. But why am I breaking this one and this one? Because they have what? I. That's the imaginary part. But be careful. We brought out the I. Because I is common, I is common. We brought out the 4 because 4 is common. So the question seems to find what? Cos what? 4 theta, isn't it? In the respect of what? If you look at this carefully, cos, in the beginning of our question, what did I say? Cos 4 theta plus I sine 4 theta. My cos 4 theta, is it acting as real part or imaginary part? I sine 4 theta, real part or imaginary part? So those one that is real part, you equate it to all the whole real part. Those one that is imaginary part, imagine you have to find sine 4 theta now. Which one are you going to use? Imaginary part. You equate to all what? Imaginary part. So real part is equals to what? Real part. So real part equals to the what? Real part. So what is the real part here? Cos 4 theta equals to what's the real part here? Cos 4 theta minus 6 cos square theta sine square theta plus sine 4 theta. This is what you have to find. And DP, the question never said in the respect of cos theta, you have done, this is your answer. Are you with me? But the question says in the respect of what? That means we shouldn't have what? Sine. Do you understand? At DP, it was like, okay, let me rub this side off. We've gotten our final answer. But the question said in the respect of what? Cos theta. So we shouldn't have what? Sine in our answer. Recall in trigonometry that sine square theta plus cos square theta equals to 1. So I can say sine square theta is equal to 1 minus cos square theta. So any place I see sine square theta, what will I put there? Can I clear this side? So what would I have? Can I write it? Watch. This is cos 4 theta minus 6 cos square theta. You know this is sine square theta. That will be what? 1 minus cos square theta. Guys, this guy, can it be written as sine square theta all the power of what? Square. Is it correct? Yes. So that will be what? 1 minus cos square theta. Is that all? So we'll open your bracket. So cos what? 4 theta, cos minus what? This, multiply this. 6 cos square theta. Minus times minus plus. What we have here? 6 cos 4 theta. Difference of two squares, Abi? Are you back? Wait, let's see. 1 minus cos square theta. Abi? Open another one. 1 minus cos square theta, abi? So 1 times 1, 1 times this, minus cos square theta. So minus cos square theta times 1, minus cos square theta. Minus times minus, plus cos 4 theta. So everything here, inside here. So we bring it here. So that will be what? What do I have? Cos minus 6 cos square theta plus 6 cos 4 theta. And what do I have now? Everything plus 1 minus what? Do what is same thing, Abi? 2 cos square theta, then what? What's common, everyone? Square is here, square is here. 4 is here. So arrange it. How many 4 do we have? This 4 we have here as cos 4 theta, Abi, plus another what? Cos 4 theta, isn't it? Here is what? Square, Abi? Yeah. Plus 6 cos 4 theta, Abi? What else do we have? Minus 6 cos square theta minus what? 2 cos square theta, then plus 1. What's your answer, everyone? This is 8. 8 cos 4 theta minus what? 4 cos square theta plus 1. Minus 8, Abi? So this is how they solve it. This is how they solve it. 12 now. So we are done with complex number. Eh?
This one you're passing.
Yeah.
What makes it not